Guys, welcome to your screencast on the muscular system. As you can see, it's revision screencast 1. We've got a few to do with regards to the muscular system, so let's carry on with it. So, the specification for the muscular system is all that you can see in front of you right now. Today we're going to be going up to types of skeletal muscle contraction. So we're going to be doing this. This here, you're going to have to do it in your own time, looking at kind of like a diagram of a muscle man and just making sure you know where all the muscles actually are. You're not going to get a question in your exam that's just going to say locate the bicep here. So just make sure you're aware of the muscles and where they are, and it's these muscles you need to know. You have it in your notes, your trigger slides and answer slides that you've already done previously. Again, this whole allocation, mark allocation still applies. So you look at the question, circle important information. We're going to be going through this today. Get the memory method, translate the memory method, extend with an example, which we will be going through with one of the answers today. So first of all, different types of muscles with examples. So there are three main types of muscle tissue in the body. What are they? Can you provide an example for each type? Give this a go if you think you can do it without any memory methods or any fill in the blanks. If you pause this now, give it a go. If you can't, what you've actually got is you've got three pictures. See if those pictures help you out with regards to the different types of muscle tissue in the body. Once you've done that, provide an example for each one. Once again, if you can do that now, pause and provide an example for each type of muscle tissue. If you can't, here are some fill in the gaps for you. So examples for picture number 1, G, Q, H. Example for number 2, pretty self-explanatory that one. Example for number 3 is that one. See if that helps you out. This may help you out, which means you can get to the answers of these three here. So if you pause that, give it a go. So answers: skeletal muscle, cardiac muscle, smooth muscle. They're the three different types of muscles we have within the body. Examples: it could be any type of skeletal muscle, but the examples we've got here: gastrocnemius, quadriceps, and hamstrings. Heart, make sure it's the walls of the heart. Okay, so you've got the walls of the heart is an example of the cardiac muscle. The only example we have, it's the only example, only muscle is a cardiac muscle. And then the walls of the stomach is an example of a smooth muscle. So walls of the digestive system as well. So with regards to these different types of muscles, so we've got different types of muscles, we also have different examples of them. We also need to know the characteristics of these muscles, i.e. kind of like what is the characteristics and what do they look like, what is their job role. So here you've got skeletal muscle. They're striated in appearance, blank, which means under something control, i.e. it moves when we want it to move. So if I want to put my hand up, I can put my hand up. That is skeletal muscle, and it is responsible for something of the muscles attached to bone. The cardiac muscle, only found in the something of your something, i.e. not under something control, does not something. So again, this I do not think about. It happens automatically without me planning on actually getting this type of contraction from the cardiac muscle, which we know is the heart. Smooth muscle, blank, works without blank control, located in the blank of the blank system. Smooth muscles, okay, we'll go through the answers now. Striated, voluntary. Skeletal muscles are voluntary and they're under conscious control. If I want to return a tennis serve, it is my decision whether to contract my muscles to make me move to hit that ball back. It's under my control. And as it says here, responsible for movement. Tendons of the muscle attached to bone. They pull on the bone, which makes us have a muscular contraction or movement. Cardiac muscles, only found in the walls of your heart. It is involuntary. It is not under our conscious control. I cannot say to my heart now, okay, just skip a beat. Okay, it is not under our control. It is involuntary. The same with the smooth muscles. Smooth muscles are involuntary and they work without conscious control. We are not thinking about it. Located in the walls of the digestive system. I do not tell my digestive system to start digesting the food. Can you just work a bit harder so that food can get digested quicker? That doesn't happen. It's involuntary. It is not under our conscious control. So there are the different types of muscle along with the characteristics and function of them, i.e. movement. Function of the cardiac muscle is to pump blood around the body, i.e. oxygen. And then with regards to smooth muscle, digestion would be a function of the smooth muscle. Please answer this exam question for me, pause it, and then we'll go through the answer in a minute. Okay, so examples: smooth muscle, walls of the stomach, get 2 marks for that, 2 marks for cardiac muscle, walls of the heart. Okay, remember it has to be walls of the heart, it can't just be the heart. Types of skeletal muscle contraction. So using the diagrams below, can you label the 3 types of muscular contractions? So this here is a bicep curl, and the picture is having the curl going upwards. This here is a leg extension machine. However, the athlete has got the legs extended. Now she's holding it in that position, so there's no movement taking place. And this one, the bicep curl started up here, and this person is lowering the weight down here. So what type of skeletal contractions are taking place in all 3 of these? Can you get that down for me? Pause it. So we've got a concentric muscular contraction on the upward phase, isometric, i.e. no movement taking place, and this third one, when it is going down, when this muscle is lengthening, it's eccentric muscular contraction. Fill in the blanks for these 3, please. So these are just a quick what actually happens. So what does concentric muscle contraction actually mean? So can you fill in these blanks and pause this? So I'll go through the answers of this. So a concentric muscle contraction, the muscle shortens under tension. So as the bicep curl goes up, the bicep here shortens under tension. Isometric does not change length under tension, i.e. this athlete now, she's holding the weight there. There is no movement, therefore it's an isometric contraction. There is still tension. You can see her the definition of her quadriceps here. So there's tension there, i.e. they're contracting, but there's no movement, i.e. it is isometric, does not change length. Finally, eccentric muscle contraction. So the bicep curl has been up here, and we've gone for the movement down. As it's moving down, the bicep, you can physically see it. It actually lengthens under tension. So an eccentric muscle contraction lengthens under tension. You can see it getting longer. Remember, in lesson we spoke about agicon, agony. We'll discuss that further on the next couple of slides. Okay, so exam question, describe an eccentric contraction. We've just gone through it there. Hopefully you can get 2 marks for that. Pause this and go through that. So the answer you should have had, tension in the muscle is created as it lengthens, returns to original length. They would accept lengthens under tension. So they would accept that, lengthens under tension. You'd get 2 marks for saying that. Antagonistic muscle pairs. This is when we're going to be going on about agicon, agony. Remember that when our muscle contracts, it exerts a pulling force on the bones to which it is attached, causing them to move together around the joint. So muscles basically work in pairs, antagonistic muscle pairs. So agonist, or something responsible for something, it is the something muscle. Antagonist, the muscle that's something in opposition to the something. So if you pause this and have a go at that, we should have agonist or prime mover is responsible for movement. It is the contracting muscle. The antagonist is the muscle that relaxes in opposition to the agonist. This part's quite important with regards to the agonist. It's the contracting muscle. Okay, so on this bicep curl, let's say you've got a weight, I'm doing the bicep curl. The agonist is the bicep. As the bicep concentric contracts and shortens, it pulls on the bone here and pulls the arm up. Therefore, the bicep is the agonist, and the relaxing muscle, i.e. the antagonist, is usually in opposition. Usually the muscle opposite is the antagonist, which is the tricep here. So the tricep is relaxing, it's the antagonist of the bicep. So what I want you to do is, from the pictures below, please identify the agonist, antagonist, and what type of muscular contraction is taking place. So this person here is on a leg extension machine, and they are kicking up. So which muscle is the agonist, i.e. which muscle provides the movement for that to happen? Which one's the antagonist, i.e. the opposing muscle? And what type of muscular contraction is taking place? These two, this one is, it's going from this starting position to finishing position here. This picture is going from this position here coming out to that position. These two are quite difficult, but we'll go on to the answers in a minute, so pause that for me. So the agonist for this one is the quadricep, antagonist is the hamstring, and the muscle contraction is a concentric muscular contraction, i.e. we're moving the weight up. Concentric contraction, the muscle kind of shortens under tension, and the antagonist is the hamstring, concentric. Here, when we're doing this position to this position, it's the pectoralis major. The antagonist, i.e. the relaxed muscle opposite, is the trapezius, which is on our back. Muscular contraction, concentric. Now, when we are resisting gravity on the way back into this position, the agonist is still the pectoralis major. Antagonist is still the trapezius, the relaxing muscle. However, our contraction is now eccentric, i.e. the pecs are lengthening under tension. this is where we're going to go about this in a bit more detail. Remember when I told you in lesson, agonist concentric, agonist eccentric. Try and remember the memory method. Agicon on the way up, agon-e on the way down, i.e. agonist towards your knee, the down. So any upward phase, agonist concentric. On a downward phase, it's agonist eccentric. So this is where we use that kind of process that I did at the start of the screencast. During the upward and downward phase of the bicep curl, describe the role of the bicep. So important information, upward and downward phase. We have to be talking about a bicep curl during the upward phase and the downward phase, and describe the role of the bicep. This is the memory method for you, agicon, agony. So try and answer that question for me. Pause it. So the answer, during the upward phase and downward phase, first of all, we've got upward phase. Bicep brachii is the, or just bicep, is the agonist muscle, i.e. because it's producing that movement. It performs a concentric contraction as muscle shortens under tension, causes flexion at the elbow joint. The downward phase, agony, so upward phase agicon, downward phase agony. The agonist is still the bicep, it's just acting against resistance to go down. It performs an eccentric muscular contraction as the muscle lengthens under tension, causes extension at the elbow joint. It's really important you get to just that. I will give you more examples of this within lesson that you can do once you have completed this part. Finally, I want you to pause this and answer these questions for me. Here are the answers, so go through the answers. So the quadriceps and hamstrings are the antagonistic pairs, i.e. they work together. The quadricep acts as the agonist and concentrically contracts, and the hamstring acts as the antagonist or relaxes. For 13b, the quadriceps and hamstrings are the antagonistic pair. The quadriceps acts as the agonist, eccentrically contracts, and the hamstrings acts as the antagonist, relax. So it's exactly the same, just the opposite with regards to contraction type. So if you can be aware the fact of the confusion between the agonist concentric and the agonist eccentric, it's really important because a question of this will come up in your exam. So get to know those, and as I've said, if you're struggling, there are more examples on papers on the tables. Thank you, and I'll speak to you later. Bye.